Hey everybody, I wanted to pick up where we left off on Tuesday and try to kind of clarify it because I bet you Tuesday's video might have been a little confusing. And so I want to take a step back and just kind of clarify and see if we can solidify this concept. So we had also looked yesterday at completing the square when we have an a value out in front. This was much more challenging because we couldn't just divide our b term by 2 and then square it, right? Like when you have a 2 or a 3 or a -1, you can't do the take half and square it. That method doesn't work. So in this case, I want to draw the picture or diagram that's closest to the standard form equation and then adjust and complete the square if needed. So pause the video, give this question a try based on what we talked about on Tuesday, and then when you're ready to see the answer, go ahead and unpause. All right, so we want to start by, I'm a visual person, so this is the method when it comes to drawing the diagram that I showed you guys yesterday. So there's two x squared boxes. I'm going to start there. And there's -16 rectangles total, which means there's going to be -8 rectangles here and -8 rectangles here, which means there's going to be -4 on each side. If you're not sure when you're going through this process, okay, if you do -4 plus -4 plus -4 plus -4, you get -16. So remember that your entire picture, the entire diagram you see right now, needs to represent what is being represented in the standard form equation. So if this was a perfect square, there'd be 16 little pieces right here and 16 little pieces right here. So as a closest perfect square, we would write y equals, this is x minus 4 times x minus 4, so it's quantity x minus 4 squared, but there's two of those diagrams. Okay, so that's what it looks like. Here's where things change. Okay, 16 plus 16 is 32. We do not have 32 pieces to work with. We have 24, which means we're actually down some pieces. Okay, that actually means we're down 8 pieces from making this 16 and 16 a reality. So the way I adjust that is down at the bottom. I say that I am down 8 pieces, and that is from standard form to vertex form. So that is what the video was based on Tuesday, talking about the diagram and the picture. Having said that, I want to show you the algebraic method as well. Some of you might prefer the algebraic method. Also, what if this standard form equation, it was -2x squared? We don't know how to do that. Like, I don't know how to draw a negative x squared box. So I want to show you guys how to do the algebraic method as well, so that when you run into that situation, you know what to do. All right, so algebraically, what I want to do is do that same exact question, okay? So separate the constant and factor out your a, b values. Remember, you can't just add or subtract numbers in math because you feel like it, but what number can we add or subtract and it's no big deal? 0. So how will this be different with a 2 in the front? So here's what I mean by that. Our equation from before is that 2x squared minus 16x plus 24. So what would happen is I would give you that equation, and your very first step would be to write out the first term, and it was minus 16x plus blank, and then there's a plus 24 at the end, so plus 24 plus blank. Hopefully that rings a bell from when we did that in chapter 8, where you would write the first two terms, a blank, the last term, and then the blank. Next step you need is you need to factor out the 2 from right here. So here's what that looks like. I put a 2 out in the front and I put parentheses. And I say, okay, if I were to take a 2 out of this term, then an x squared is what would be left. If I were to take a 2 out of this term, meaning kind of like I'm dividing, this would turn into -8x. I still put the plus blank, and I close the parenthesis, and this plus 24 plus blank is going to stay exactly the same. So if that step is kind of confusing, the whole idea is when there's a 2 in front of the x squared, I can't just take half of -16 and square it like we did in chapter 8. So if I can almost like get the 2 out of the way, kind of like anti-distribution, I don't know how else to say that. So if I can divide the 2 out of things, I can actually then use that same method. So for example, back in chapter 8, if I asked you to complete the square for this one, you'd say, well, half of -8 is -4, and -4 squared is 16. Now we can use that method because there's just a 1 in front of that x squared. Okay, here's where things get a little bit goofy. Okay, so bear with me. The 2 that was in the front right here, you're just going to drop it down and it's still going to be out in front. Here's where things get a little bit tougher. We just added 16 right here. So some of you are probably going, oh, we're going to subtract 16 right there. So it's like we added 0. Here's the only downside to that. Let me switch my colors. We didn't just add 16. We added 2 times 16. 2 times 16 is 32. So we essentially just added 32 right here. So I need to subtract 32 right there. Okay, so that's the new part. That's the part that's different from what we did in chapter 8. Everything else is very similar. 24 plus -32, I'm typing it in my calculator just to be safe, is -8. And so I bring that down, and there's my vertex form. Notice how I got the same exact vertex form answer as I did using the diagram. So it's totally up to you. The algebraic way works every single time. The diagram works as long as the number is a positive number, okay? So my recommendation would be to know both methods. If you're struggling with this or you need some extra practice, there's tons of videos out there. If you just look up or Google completing the square, you'll find other ways of doing this that might connect with you more or might make more sense than what I'm showing you, and that's totally fine. All right, I want you guys to do some practice. So for these ones, I want you to use the algebraic method and not the diagram. Now, having said that, this one you could use the diagram because it's a positive number. This one you could use the diagram because it's a positive number. But look at this one. Would using a picture work as well for this one? And the answer is no. I don't know how to draw -x² boxes, right? So that's kind of the idea. So take a minute, pause the video at this point in time, and use the algebraic way to practice these 3 questions. When you're ready, unpause the video, and let's see how you do. All right, so let's start with the first one. First step is to separate the first 2 terms plus a blank plus the last term plus a blank. My next step is to take the 5 out of those first 2 terms. So if I take the 5 out, that turns into x² minus 4x plus blank. Put that closure parenthesis right there so that it reminds you that the 26 and the second blank just stay put, okay? All right, now I can do the take half and square it method. So half of -4 is -2. -2 squared is 4. But remember, I didn't just add 4 to the equation. I added 5 times 4, which is 20. So to balance it out, if I added 20 to that side, I need to subtract 20 as well. So it's kind of like I only added 0. The 5 that was in the front comes down, and this 26 plus -20 is 6. So we put the +6 at the end. Remember, you can also do this using the diagram, so if you want to practice that at this point in time, you totally can, just to see if you're doing all right. Okay, second one, same thing. Separate the first 2 terms from the last with those blanks, and then take the 9 out of the way. So if I get the 9 out, remember it's like you're dividing, it's like you're anti-distributing. So what's left over is x² minus 2x plus blank. Don't forget that closure parenthesis, so the 77 and the second blank, nothing happens to them. Half of -2 is -1, and -1 squared is 1. But remember, I didn't just add 1, I added 9 times 1, which is 9. So I need to subtract 9 at the end. This 9 in the front drops down. 77 plus -9 is 68, so I put that plus 68 there at the end. Okay, last one. This is an example of one where you would have to use the algebraic method. That's why I want you to know both. So first step, okay, separate the first 2 terms with a blank, last term, and a blank. So here's what's different about this one. I'm going to take a negative out of those first 2 terms. So it just changes the symbol. Now I can do the whole take half and square it thing, right? So half of +6 is +3. 3 squared is 9, but I didn't just add 9, I actually added -9. So I need to add +9 so that it balances out. So there's a +4 at the end. Don't forget that negative in the front that needs to be carried down, and you're all set. All right, so after you watch this video, you guys, I want you to try the Chapter 9 homework number 1. Remember, if you have a printer and you can print it out, that might be easier. If you don't, that's okay. Do the questions on a blank sheet of paper and just label them. Like, you don't have to rewrite the question. And take a picture of your blank sheet of paper. When you take a picture, please make sure you are uploading the homework to the Google Classroom assignment. That's where I'm going to be getting that. So don't email it to me. Just put it on the assignment. Also, just so you guys know, at the end of every week, I'm going to go through and grade your homework assignments. So here's what that means by that. I don't get notifications when you post something on Google Classroom. I've turned that off. Otherwise, I would have 5 million emails every day. So what I'm going to ask is if you see a missing for a homework assignment in the gradebook, if you turn in the assignment late, you'll still get full credit. That's okay. But you have to send me an email saying, hey, Mrs. Nurs, I turned in Chapter 9 homework number 1 after you graded it. Can you please update that in the gradebook? And then I will manually go back into Google Classroom, see that you submitted it late, okay? So again, if that procedure is kind of bizarre, feel free to send me an email or to come talk to me during office hours so I can explain how that works, okay? Good luck on your first official homework assignment. You can do it.